We are go over page 10, long question number 1. There is a number you need to read from the information sheet, which is how much energy does water need to get from liquid to gas. Okay, just to make sure we're on the same page. When water is in ice format, okay, solid, it's pretty much ice, but you can get ice into even colder if you want. Okay, when does the temperature stay the same? That will be when you have ice and water, which pretty much solid and liquid. What this platform is doing, okay, this is what we talk about. You have delta H for fusion. This is what your current lab is doing, the coffee cup. You're going to throw ice into water. If you measure, as long as you do have ice in water, they're always going to stay 0 Celsius degree. There's no temperature change, but there are energy still being transferred. So this is why, so your, okay, let's say previous mCp delta T. Since the temperature stay the same, I will not be able to plot this for Q. Then the only possible way is from delta H of fusion. If you read this number from the back of your reader, I think I just showed you guys, right? Yeah. Okay, this number will be provided to you. It's here, so 6.01. Okay, 6.01 kilojoules per mole. That's how much energy is per mole of water, or let's say ice, but pretty much the same. That is being transferred over. Doing this since we don't have temperature change. Okay, now from 0 to 100. What happened during that? Okay, that's mCp delta T, because you do have temperature change now, based on how much water you have. This is what happened here. It says I have whatever 1 liter of water. Okay, M 1 liter of water. You can get mass out of that, right? And what does it says? Water boils at 90.50 Celsius degree. Why does that happen? Because it's not 1 atmosphere or not 1 bar. It's like usually water boils at 100, but this one water boils at 90. Whatever temperature that is, it is, okay? Okay, after boil, what happened? It's from liquid to gas. It's going to plateau on this temperature again. That same thing happens again. It's keep at 100 Celsius degree. Their delta T equals to 0 because the temperature is the same. But we still have, what did she do? She says she boiled all of them from liquid to gas. Okay, that's huge amounts of heat being involved. It's just there no temperature change. So whatever happened here, that will be delta H of vaporization, because we'll say liquid to gas is vaporization, right? Okay, that's 44. So as long as your plateau, you don't have such a thing, okay? As long as you are plateaued, your change of temperature is 0. Your mCp delta T doesn't apply anymore. But if you still want to calculate the heat change, you will need to use this delta H, which is another type of delta H we haven't involved, but you will see them in lab very soon, okay? All right, so overall, you are now ready to do this one. There are 2 phase change, 2 parts included in this. One, it says boil all the water, which is from, let's say, probably from a room temperature. Okay, this is one stage, which you can use mCp delta T. And the second stage is all the water from liquid to gas. Okay, this will be Q. Let me see what letter they use. They didn't use a letter for it. Okay, let me just write this Q1. Okay, and this one will be Q2. So your Q overall equals to this two stage. Okay, Q1, you use mCp delta T. How does the M goes? You have 1 liter of water from volume to density. Cool? Okay, volume, density, you'll get mass. Okay? Okay, Q2, if you have mass, okay, after you get to mass, you'll get to more as long as you have molar mass, right? Once you get to more, what do we have here? Delta H vaporization. This one is per mole, right? Okay, times number of moles. N from here, mass from here. And you add this two up. That's it. Okay, I'll let you do it. Cool?